it's taken out and was in here. All right, so this is actually a section down here as well. Okay, now if we look at the number of squares in each one of those sections, we'll start to get some correlation between things. Okay, so in this section over here, you have 2 squares. In this section over here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Over here, you have 1, 2, 3, 4, 5, 6. 6, okay. Down here, you have 14. Okay, so you have your 2, your 10, your 6, I mean 6. What am I doing here? 2, 6, 10, and down here 14. Okay. These numbers should look familiar. Okay. How many electrons can you put in an s orbital? I mean s subshell. 2. How many can you put in a p subshell? Well, it has 3 orbitals, so you put 2 in each one, so you can put 6. How many electrons can you put in a d subshell? Well, you have 5. You can put 2 in each one. You have 10. How many can you put in an f? 14. So each one of these sections represents a subshell. Okay. The other thing about the periodic table, if you look, is that you the last electron. So look at magnesium up here. Where is its last electron in this in our diagram? It's energy level 3, right? Where's magnesium? It's in the 3rd row. Okay. Chlorine. Where's the last electron go? What is the valence shell for fluorine? What was it? 2. Okay. Where is it found? Row 2. It turns out that you can know what energy level a atom is by what row it's in. So the row is going to tell you how many energy levels it has. Okay. So that just kind of jumps. That the periodic table all of a sudden just throws this information at you without drawing all this. Okay. All right. So what I want to do is I want to figure out the electronic configuration for oxygen using the periodic table. Now, if you guys haven't done this before, it's going to take a couple minutes, a couple of examples to get through it. If you've done it before, you already know what I'm going to do. Okay, so I have oxygen here. So what you do is you find out where it is on the periodic table, what row it's in. Okay, so oxygen is in row 2. So you write down 2. Okay, then you write down what section it's found in. Okay, and it's found in P. So I sort of look at these as sort of neighborhoods. Okay, so this is the S neighborhood, this is the D, this is the P, and this is the F neighborhood. And these are like each element's like a house. So and what I want to do is find the address for this house right here. So its address is going to be 2, P, and 1, 2, 3, 4. So 2P4. Okay. So what you do is you write down the address. So you write down the energy level. Okay, you write down the subshell, and then how far it's over. Okay, so there's more to it. If you look, there's more to this. So this is oxygen. Let's look at magnesium. So where's magnesium? It's in row 3. so write down 3. It's in the S section, and it's 2 over, so write that down. So this is a good place to start. Okay, that's what we got right here. Okay, how about the other stuff? All right, so we know that we have, for oxygen, it should be 1s2, 2s2, 2p4. We got that from the orbital energy diagram. How do we get those other things? Well, what you do is you sort of envision, I went to visit my friend at Oxygen House, and what I want to do is go back home, okay? And as I go back home, what I have to do is I have to write down the neighborhood that I'm in and how many houses I go by, okay? So I have to go back home. Right? So what I'm going to do is so I already wrote this down. So I got 2p4. And then I'm going to go back over here, and I'm going to go through the 2S neighborhood, and I'm going to go past 2 houses. So I write down 2S2. Okay, and then we're going to move this guy over here, and then I go through these 2 guys, and that's 1S2. Okay. All right, magnesium. So I'm right here. I'm in the 3s2. Now I have to go back home. So I have to go back numbers. So it's 12, 11. Then you got to go through these guys here. Okay, so you go, what neighborhood is this? This is the 2P, and you go by 6 houses. So write down 2P6. And then you keep on going. Then you go through the 2s2s, and then 1s2. Okay. And you can see that those 2 are the same. Okay. So the periodic table can give you this information as well. And then what you can even backtrack and figure out the orbital energy diagram from that information. Okay. See if let's have you guys do. How about argon? Okay. See if you can figure it out using the periodic table. And I'm going to do both. I'm going to use the orbital energy diagram and the periodic table, but they should give you the same answer. Okay, so argon is found in row 3, so write down 3. It's found in the P's. So it's 3P, and how far is it over in the P's? 1, 2, 3, 4, 5, 6. So write down 3P6. Okay. Then go backwards. And then you go through the 3S2s. Then you go through your 2P6s, 2S2s, and 1S2. Okay. If we did the orbital energy diagram, we'll come up with the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. Okay. So 1S2, 2S2, 2P6, 3S2, 3P6. Okay, so they jive. Right. How many valence electrons does argon have? First of all, what's the valence shell? 1, 2, or 3? Okay. So 3 is the valence shell. How many valence electrons? 8. 2, so 8 valence. Okay. All right. So the electronic configuration will also give you the valence, how big it is. It has 3 shells, and it'll also tell you how many valence electrons it has, which tells us something about its chemical properties. Okay. All right. Okay. Now, I said just do, for the orbital energy diagram, just do the first 18 because it gets goofy going up. All right. The periodic table actually helps us get through the goofiness. All right. Let's see how. Okay, so let's take a look at. Okay, now before we do potassium, I want to show you. I'm going to show you the orbital energy diagram for it. This guy's number 19. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18. Then it has these over here. And if we would follow the method that we're doing, we would put that electron right here. But it turns out the electron is right here. Okay, and I said, whoa, that's just, why is that? Okay, it gets complicated to explain it. But the periodic table gives us this. All right, so. Okay, so let's do potassium using the periodic table, and we will get the right answer. Okay, where's potassium? Right here. It's energy, so write down 4, then write down S. And how far is it over? 1. So write down 4S1. And go backwards. Okay, so go through these guys. 3P6, 2S2, 2P6, 2S2, 1S2, okay? So that gives it this without figuring all that mess out, okay? I like to underline the rows to just keep things organized. Okay, so the valence shell is 4, and it has 1 valence electron. All right. Okay. So using periodic table helps us figure out and what you can do is you can now just translate that back on here and figure out the orbital energy diagram. Okay, but you're not building it. You're figuring it out. Okay. Well, let's try some more. Okay, so let's expand our horizons. Okay, let's go to copper. Okay. All right. So copper, has 29 electrons. So it's a number on top, it's a number of protons. Okay, now what we have here is something we have to make a little bit of thinking about this. What did I tell you about these guys here? What neighborhood are those?
D's.
The D's, okay? Because they have 10, all right? When did the D's first show up? What energy level did they first show up? Energy level 3, right? Where are they found in the periodic table? What row? Row 4. So these guys here, are they 4s? No, they're 3s, okay? Turns out the D's are one less than the row they're in, okay? So that's a little bit of a complicated thing there, but this is that. So copper, where is copper found? Where is this guy right here? Well, it's in the 3Ds. Okay. So, and it's 9 over? 1, 2, 3, 4, 7, 8. So 3D9. Okay. But the thing is, but you just keep on, you go back, you do the same thing. All right, so then you come out of that neighborhood. What neighborhood you're in now? You're in the S's and 4S. So you write down 4S2. And then 3P6, 3S2, 2P6, 2S2, and 1S2. Okay, so that's because the D's don't start until 3, okay, but they're in the 4. These guys actually represent 3s. So these are the 4 Ds, even though they're in row 5. These are the 5 and 6 Ds, okay? These guys over here are still the same. So these are 4 Ps, these are 3 Ds, and these are 4 S's. So that's one of the kind of tricky things about it, all right? If we count up our electrons, there's 29. 2, 4, 10, 12, 18, 20, 29. Okay. What's the valence shell? 4. Okay. The last one out here, okay, this number kind of tell you. Okay. It's what row it's in is actually, but you notice this guy here. So it's not the last one I wrote. If you want, you can write it so it's all in order. You could write it like that, or you could write it like this. I write it like this just because that's the way I figured it out. What's the outer energy? Okay, 4 is the highest energy. And how many valence electrons? 2. See, try zirconium. It's ZR. It's in the middle. So for electronic configuration, you can do past 18, and I'll set a limit on those as well. zirconia is number 40. So it's found in row 5, but it's in the Ds, so it's going to be 4D and it's 2 over. Okay. And then what I do is I work backwards. So I have to get back home. So I go through the 5 S's, and there's 2 of them. And then I go through the 4P6. Then, once I get out of the 4P6, I go through the 3D10s, and then the 4S2s. Okay, then you go up row, and then you go across, 3P6, 3S2, and 2P6, 2S2, and 1S2. Count them up, 2, 4, 10, 12, 18, 20, 30, 36, 40. That's right. How many valence, what's the valence shell? How big is it? It's 5, and how many valence electrons? 2. Okay. All right. Okay. A couple things. All right. It turns out that all the elements that are found in here will always have 2 valence electrons. Okay, because what you do is you find the D's and you have to go back, you have to go down and then come back up. All right. So so all of these, so we can pick any one. Any one of these guys will have, it'll always end up being like it. So everything in this column will have a 4S2, row, everything in this row will have a 5S2, everything in this row have a 6S2. Okay, that's just the way it is. No matter how hard you try, you just can't get it. Okay. The elements in the middle are called transition elements or transition metals. Okay, and so they have their predicted valence shells will always be 2. Okay. Now the thing about the transition metals is they get weird. Okay, in terms of their electronic configuration. The electronic configuration for copper is not what we predicted. Okay, it is actually, instead of 4S2, 3D9, it's 4S1, 3D10. Okay. Silver is the same way. Silver, you would expect it to be 4D9, 5S2. It's not. It's the same as copper. It has a 5S1, 3D10. Why is that? It's complicated. And I have a reason. I can explain it, but I don't know if it's right. Okay. And I've looked at all over the internet to see if there's a way of explaining why the difference is, and I haven't found it. I like my method. I'm pretty sure my explanation is probably pretty close, but just know there's difference. A really odd one is this guy right here, palladium. It has 18 valence electrons. Okay. It's its electronic configuration. So let's look at palladium. So palladium is PD, and it's found in the 4P. How far over is that? 8? No, 4P8, 5S2, 4P6, and 3D10, 4S2, 3P6, 3S2, 2s, 2p6, 2s2, 1s2. Okay, so what it really is it's 1s2, 2s2, 2p6, 3s2, 3p6, 3b10, and then 4s2, 4p6, 4d10, something like that, okay? And I messed it up somewhere, but it's 18 valence electrons. We'll talk about this in a couple of days, maybe a week or so. A common thing that's thrown out as in chemistry is that, we say that there are only going to be 8 electrons in the valence shell. You may have heard that. You can see that's a lie. Palladium can have 18. And we'll get into that. Is that we're gonna tear down the myth of 8 electrons in the valence shells being something special. Okay. Well, it is kind of special, but not for the reason that's usually explained. All right. Let's do another one. Okay, let's pick one. Iodine. See if you can do iodine. So it's found in row 5, so 5 and 5p5. Then you have to go through the 4d10s and 5s2. You get out of that row. And you go into the 4th row, and you have 4p6, 3d10. And then you go in the 3rd row. In the 2nd row. And Valence electrons, 2 plus 5 is 7. Okay. All right. Okay. I want you to do the electronic configuration only through Xenon. All right. It gets a little complicated when you get into row 6 because you got to throw the F's in, and it's not hard to do. It's just another pattern. Okay. So, for instance, if we wanted to figure out mercury, okay, mercury. So mercury is in the 5d10s. But when you get here, you have to come down to these guys. And when do the F's show up? What row do the F's show up? So energy level 1 is the S. Energy level 2 is S and P's. Energy level 3 is SP, D's. And then with the first F's show up at energy level 4. So these guys are actually 4 F's. So it'd be 5d10. 4F14, then come back out, 6S2. Okay, how many valence electrons did it have? 2. Because that's the highest energy level right there. And then you go back and do the same thing, all right? So with the F's, I don't want to do that. I mean, if you want to figure it out, it's not hard to figure out. It's just, so all you have to do is again, like if you were at uranium, okay? Uranium is in the 5 F's, because this is 4F, 5S, 5S, 2, 3, come out over here, and then you go 7S2, and so forth, cycle up, okay. All right, you won't be responsible for that one. Okay. I'm gonna get through these.